wonderful AP Human Geography students. This is Dr. Gillespie, and we're going to talk about some population basics today in our lecture. I hope you're enjoying the class, and I hope that you know I appreciate you being in it. First of all, population geography is a branch of human geography focused on the scientific study of people, their spatial distribution, and density. To study these factors, population geographers examine the increase and decrease in population, people's movements over time, general settlement patterns, and other subjects such as occupation, and how people form the geographic character of a place. Closely related to population distribution is population density. This is another topic we will discuss and you will have in your chapter on population. Population density studies the average number of people in an area by dividing the number of people present by the total area. Now, don't worry about any of the formulas or things that you're going to hear me talk about. We just have a couple quick computations, but you don't have to do these really now. Just listen and get the general overview of population. Then when you go back to the chapter, you can note down the formulas, okay? And when I do show the demographic transition model, why don't you pause the video and just study it for a while. Take a few notes and then go ahead and go through the rest of the video. That's what I do all the time when I'm also a student. And when I'm studying something, I like to stop the video or whatever it is and think about what I'm reading and seeing and take some notes. It's just really a key for me to learn, so I hope it helps you. But anyway, the average number of people in an area divided by the number of people present by the total area. So the number of people in the area divided by the total area gives you the population density. And usually the numbers are per people per square mile or per square kilometer. But now there are several factors which affect population density, and we study those in population geography as well. These factors can relate to the physical environment, like the climate, the topography, or they could be related to the social and the economic and the political environments of an area. For example, places that have harsh climates, like the Death Valley in California, that region is sparsely populated. By contrast, go to Tokyo, Japan, or Singapore, and these places are densely populated because of their mild climates and their economic, social, and political development. Overall population growth and change is another area of importance for population geographers. This is because the world's population has grown dramatically over the last 2 centuries. To study this subject, population growth is looked at through the lens of natural increase. And this means we're talking about the area's birth rates and death rates. Natural increase. The birth rate is the number of babies born per 1,000 people in the population every year. The death rate is the number of people who die per 1,000 people every year. The historic natural increase rate of population used to be near zero. So the births roughly balanced out the deaths. About the same number of babies being born equaled the same number of people dying every year. So the rate of natural increase was almost zero. Today, however, we have an increased life expectancy due to better health care and standards of living, healthier diets. The need to exercise has been realized, so we're living longer. And that's lowered the overall death rate. In developed nations, the birth rate has dropped off also, but it is still high in developing nations. As a result, the world's population has really grown exponentially, and exponential growth is much, much faster and more dramatic and higher numbers than arithmetic growth. Um, in addition to natural increase, population change considers the net migration for an area. This is the difference between in migration, people coming into your area, as opposed to out migration or people leaving your area. So that net migration growth is also very important um, in the area's average growth rate or change in population. Now, an essential component to studying world growth rates and population change is the demographic transition model. This is a really important tool in population geography. And this model looks at how population changes as a country develops in 4 stages. I'm going to hold this up and hopefully you can sort of see it. There are 4 stages. The first stage, which is right over here, stage 1, this is where you see a high death rate and a high birth rate. There's very little natural increase and a fairly small population. The second stage features high birth rates and low death rates. So more babies are being born than people are dying. So there's high growth in the population. Most of the lesser developed countries fall in stage 2. The third stage has a decreasing birth rate and a decreasing death rate, again resulting in slowed population growth. Not as many babies being born, but not as many people are dying either. And finally, the fourth stage of the demographic transition model has low birth and low death rates with low natural increase. Now, developed nations usually have an equal distribution of people throughout the different age groups. And this indicates a slow population growth. However, some show a negative population growth when the number of children is equal to or slightly lower than the older adults. And I want to show you Japan's population pyramid. The lowest cohort, which is the grouping down here along the x-axis, the first grouping, 0 to 4 years, we see that it is smaller, fewer babies being born, and the older folks are staying around a little bit longer. And so we see that the number of children are equal to or a little bit lower than the number of the older adults. Excuse me. Japan's population pyramid shows slowed population growth. Now, in addition to census data, you can get population data through various government documents, birth certificates, death certificates, governments, universities, private organizations have surveys and studies out there to gather data about population specifics and behavior that could be related to topics in population geography. Now, we want to look at the demographic transition model to explain the transformation of countries from having high birth and high death rates to low birth and low death rates, stage 1 through stage 4. In developed countries, this stage actually began in the 18th century and continues on today. Less developed countries began this transition later, and there are many of them still in the midst of the earlier stages of the model. Most of the lesser developed countries are in stage 2. The model is is based on the change of the crude birth rate and crude death rate over time. Each is expressed per thousand population. So the crude birth rate, we already said, was taking the number of births in a country in a year's time and dividing it by the country's population. Then multiply that number by 1,000, and that's your crude birth rate. For example, in 1998, in this country, the United States, the crude birth rate was 14 per 1,000, or 14 births per 1,000 people, while in Kenya, a lesser developed country in sub-Saharan Africa, their crude birth rate was 32 births per 1,000 people. The crude death rate is determined the same way. You take the number of deaths in that year divided by the population and then multiply that number by 1,000. And this will give a crude death rate of 9 in the United States, 9 people per year, and 14 people dying per year as a crude death rate in Kenya. So let's talk a little tiny bit about these stages. You can see stage 1, and the red line on this model's graph is the crude birth rate, and the green line is the crude death rate. And in stage 1, before the Industrial Revolution in Europe, the countries of Western Europe had high crude birth rate and high crude death rates. The births were high because more children meant more workers on the farm, and with the high death rate, families needed more children just to ensure the survival of the family. Death rates were high due to disease and a lack of hygiene. People didn't wash with soap and water as we do today. People did not have clean water to drink, and many times food was contaminated and not safely stored. So there was a great number of deaths due to disease and just plain lack of hygiene. But the high birth rate and death rate were somewhat stable, so the population grew very slowly. Once in a while, epidemics would really increase the crude death rate for a few years, and you can see this in stage 1 by the waves. See the waves in the model here? In stage 1, those are representative of epidemics and plagues and that sort of thing. Now in stage 2 of the model, in the mid-18th century, we find the death rate in Western European countries dropped due to improvements in sanitation and medicine. So out of tradition and practice, the birth rate still remained pretty high. This dropping death rate, but the stable birth rate at the beginning of stage 2 contributed to skyrocketing population growth rates. And over time, children became an added expense and were less able to contribute to the wealth of the family. They actually sort of became a liability and instead of an asset. And for this reason, along with advances in birth control, the crude birth rate was reduced through the 20th century in developed countries. Populations still grew rapidly, but this growth began to slow down. Many less developed countries are currently in stage 2 of the model. For example, Kenya's high crude birth rate of 32 per thousand, but low crude death rate of 14 per thousand contributes to a high rate of growth. There, Kenya's in about the middle of stage 2. Now move on to stage 3. You look at stage 3 here, and you see both the crude birth rate and the crude death rate in developed countries both leveled off at a low rate. In some cases, the crude birth rate is a little bit higher than the crude death rate. as in the United States, while in other countries, the crude birth rate is actually less than the crude death rate, like in Germany. You'll find this in Europe, in Italy, and in France and Germany. Less babies are being born than people are dying. So they're starting to have sort of a population problem. A lot of older people are living longer and needing services and needing social services, care, and so forth. But there's less babies being born to enter the workforce and provide the resources for these older folks. So it's become almost a negative population growth rate in many European countries. Now, immigration from less developed countries now accounts for much of the population growth in developed countries in stage 3 of the transition. Countries like China and South Korea and Singapore and Cuba are rapidly approaching stage 3. So, as with all models, the demographic transition model has its problems. The model does not provide guidelines as to how long it takes a country to get from stage 1 to stage 3. The Western European countries took centuries to move through to move through this from stage 1 to 3, and we're seeing some rapidly developing countries like the so-called economic tigers of Asia, like Singapore and Malaysia, are actually transforming in just a matter of decades. So the model also does not predict that all countries will reach stage 3 and have stable low birth and death rates. There are factors, such as religion, that keep some countries' birth rates from dropping. Now, this version of the demographic transition model we just discussed has 3 stages. Actually, there's a 4th stage if you want to look at it. Not everyone believes in the 4th stage, and sometimes you'll even see in some textbooks the models will have a 5th stage. It really doesn't matter. The shape of the graph is consistent, but the divisions in time are the only changes. So as long as you understand the model in any of its forms, you can better understand population policies and changes in developed and less developed countries around the world. Thank you so much.